Let's look at this problem here. Sodium. Terminal electronic configuration of sodium. So sodium, we start at the beginning, we count our boxes, we in period 1, so we have 1. We have our S block, we count 2 boxes, 1, 2. We go to our next level, which is 2. We count our boxes, 1, 2. So we're in the S orbitals, so we put an S and we count the boxes, which gives us 2. We go across. Now we've entered into our P. So we still on level 2. We write a P because we've entered the P orbitals. And we count the number of boxes. 1, 2, 3, 4, 5, 6. So it's 2P6. We go to the next level, which is 3. We've entered into the S block orbitals. So we put an S. And then we count the number of boxes it takes us to get to sodium. So in this instance it is 1. So again, if we add it up, we have 2 and 2 is 4, 6 plus 4 is 10, plus 1 is 11, which also equals the atomic number of sodium, which is 11. Alright, let's look at another one. In this instance we're looking at chlorine. Start from the beginning on level 1, so we write down our 1. We're entering the S block, so we write S, and we count the number of electrons we have on the S block, which is 1, 2. So we write out 2. We go to the next level, we have 2. We're entering into the S block orbitals, so we write our S, count the number of boxes, 1, 2. So we have 2. We go across into our 2P, so we write a P, a 2 because we're still on level 2. We write a P because we entered into the P block elements. Count the number of boxes, 1, 2, 3, 4, 5, 6. So we have 2P6. We now go to level 3. We have 3. We've entered into our S block elements, so we have S. We count the number of boxes, 1, 2. Put a 2. We go across. We're still on level 3, so we write a 3, but now we've entered into our P block elements, so we write a P, and then we count the number of electrons required in order to get to chlorine. So it's 1, 2, 3, 4, 5. 5. So the electronic configuration for chlorine will be 1s2, 2s2, 2p6, 3s2, 3p5. Alright, let's look at something a little bit more challenging. Now we're going to take a look at calcium. So we start again from the beginning. So here we have 1s2. Go to level 2, we have 2s2. We go across. We are still on level 2, but now we're in the P block. We got 2p6, 1, 2, 3, 4, 5, 6. 2p6. Go to level 3. We have 3s2. Go across. Still on level 3. But this time we have our P block elements, so we write down our P. The number of blocks is 6. 1, 2, 3, 4, 5, 6. The number of boxes is 6. So we have 6. Now we go to level 4. Go to level 4. And now we count, we're in the S block elements. Count the number of boxes, 1, 2. So this will be the electronic configuration for calcium. So simply count the boxes. If you add up all the electrons, 2, 2, 6, 2, 6, and 2, it will total 20, is what we see here for the atomic number of calcium. Okay, now let's look at copper. So the electronic configuration for copper, so you have Cu, would be 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3p6, 3p, 1, 2, 3, 4, 5, 6, because we're now in 4s2, we went to 4s2, and now we're entering into our D block elements. Wait up, we're messing up stuff. 4s2, and now we're going into our D block element. So whenever we get into our D block element, the period here drops from 4 to 3. So we have to write 3, and then we have D, and then we count over to the element of interest, and this interest is copper. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 3D9. Alright, so let's go back over this. I noticed this kind of quickly. So first element, we're looking for copper. So this is the element that we have in mind here that we want to target. We're going to count our boxes. 1s2, group 1, 1s2. 1 is for, we're on level 1. S is for the block orbitals that we in. 2 is for the number of boxes. 2s2, 2s2, 2p6, 3s2, 3p6, 4s2, and when we get into our transition metals, whatever period we're in drops 1 to become 3. We're in the D block element, so we write D, and then we count the number of boxes to the required element. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, one of the things that you can do is rearrange this so that you have 1, 2, 2, 3, 3, 3 all together, and then you have 4 as the last one. So you would have 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2.